Hi guys, this is Mrs. Cerami with your first screencast and my first screencast to you because this is trial and error. Errors will occur, so please bear with me. We are going to start with 9.1, the counting principle, which is a review from Algebra 2, but it is part of our curriculum and actually the next place in our curriculum where we need to go. I will be splitting up 9.1 within 2 days to make it clear for you guys and easy to navigate the videos as well as the assignment. So to begin, I just want to warn you that I ordered a better trackpad. Right now I'm using my finger on the trackpad, so it's going to be a little sloppy. But come Monday night, Amazon will be shipping in the same board that Khan Academy uses, so it's going to be so much cleaner. All right, here we go. The question states, in how many ways can you make an outfit with 3 shirts, 2 pairs of pants, and 2 ties? So one way of handling this is with a tree. So if we have 3 shirts, we can call this up. Let's put the pen up here first. We'll call this shirt 1, shirt 2, and shirt 3. So again, the object is to find out how many different ways and how many different outfits we can make. So now we also have 2 pair of pants. So shirt 1 can be paired with pants 1 or pants 2. Shirt 2 can be paired with pants 1 or pants 2. And shirt 3 can be paired with pair of pants 1 or pair of pants 2. So just so you know, the right side column, that tells you how many outfits you have all together. So far we have 6 outfits we can make with 3 shirts and 2 pair of pants. But since we're at the prep, we also need ties. So we also want to know how many outfits we can make with 2 different ties. So we have tie 1 and tie 2. With pants 2, we can also pair that with tie 1 and tie 2. So actually the way we're doing it is the longest way we will do it. We will be doing shortcut ways from here on in. Here, tie 1 and tie 2. And with shirt 2 and pants 2, we could pair that with tie 1, tie 2, and we're almost done. Shirt 3, pants 1, we can tie that with tie 1 or tie 2. It's getting tough to write here with the mouse pad. And pants 2, tie 1 with also tie 2. So like as I mentioned before, the right hand side tells you how many possible solutions we have. So we have 2, 4, 6, 8, 10, 12. So we have 12 different outfits we can make with that. So we're going to come back to this slide in a little bit. We're going to go into the next problem right now. So the next problem, you go to the snack bar to buy a bagel and a drink for lunch. You can choose from a plain bagel, a blueberry bagel, or a raisin bagel. The choices for a drink include water or sports drink. How many different lunches could be made with these choices? So we can have a bagel, we can have a plain bagel, or we can have the blueberry bagel, or we can have the raisin bagel. And then if we choose a plain bagel, we can have water or a sports drink. We can choose a water or a sports drink. And we could choose a water or a sports drink. So altogether we have 2, 4, 6 options. Now, the shortcut of this. So a tree always works. However, the shortcut, because it can get pretty complicated, we have 3 shirts, 2 pair of pants, and 2 ties. So that's where the counting principle comes in. The counting principle states if you multiply how many options we have altogether, you will come up with a solution. So we have 3 items to choose from. I always like drawing blanks for the 3 items. This represents my shirts, this represents my pants, and this represents my ties. So we know the answer is 12. How do we get there quickly with the counting principle? Well, we have 3 shirts, we have 2 pants, and we have 2 ties. If we multiply that together, we get 12. Now, let's see if that works on the slide that we did with the food. Well, we have a bagel and we have a drink. There are 3 options for a bagel: the plain, the blueberry and raisin, and 2 options for the drink: water or sports drink. When you multiply them together, you get 6. So that's where the counting principle comes in. It's so handy. I love it. Now, we can use it for finding how many options there are on a license plate. So let's look at the next problem. You just received your license and want a personalized license plate with 3 letters that may repeat and 2 numbers that may not repeat. How many different options are there? So how many blanks do we put here? Let's see. We have 3 letters and 2 numbers. So this is going to be a letter, a letter, a letter, a number, and a number. Again, this writing will be clearer next week. So it says that the letters can repeat, but numbers cannot. Well, we have 26 letters in the alphabet. We could choose 26 letters for the first spot. It could be repeating. So we can choose the same letter again, 26 letters again, and 26 letters again. Now, this is an error alert. This is where students usually goof right here. There are 10 numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 is a number 2. So we're going to start with 10 numbers we could choose from. But numbers may not repeat. So once we use one number, we're just left with 9 altogether. And now, when you find the product of that, you will find a product of 1,581,840. So you can see why the states with the higher population have a longer license plate, and states with a smaller population, like Delaware, have smaller options. All right, next problem. Why don't you guys try this on your own? I'll give you about 45 seconds, and then I'll give you the answer. All right, so there's no restriction here. So we're going to have 3 letters and 3 numbers. So the first 3 letters will have 26, 26, 26, and no restriction. So 10, 10, and 10, and 10. And when you find the product, we're going to get 1, 7, 5, 7, 6, 0, 0, and 0. So we're gonna have 17,576,000. If no letters nor digits can repeat, let's see how you did with this one. It can't repeat now. So hopefully you had 26 here, 25 here, 24 here. Now we're up to numbers. Cannot repeat. We start with 10, we use 1, we're left with 9, we use 1, we're left with 8. When you multiply, you get 11,232,000. So hopefully you did okay with that. Again, this writing will be clearer as time goes on. Next slide. Your little brother tries to break into your 4-number passcode on your phone. How many options do you have to choose from? Numbers can repeat. Well, again, 4 numbers, so we have 4-number passcode. You have 10 to choose from for the first one, 10 for the second one, it could repeat, 10 for the third, and 10 for the fourth. And no calculator needed for this because it's 10 to the 4th power, which gives us 10,000. We're almost done. Hopefully you guys are doing okay. Your teacher gives you an online 5-question true or false quiz. How many different possible answers are there? Question is, how many questions are there? 5. So we have 5 blanks. How many options for this guy? 2. This could be true or false. 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 And this one could be true or false. So it's going to be 2 to the 5th power, which we know is 32. So 32 is our answer. Okay, so when you're choosing different items, place, and they're different items, we'll do same items tomorrow. Place blanks for each item, write how many different choices per option, and multiply them together. Now you get a chance working through these with my math lab. There's only a few problems on there, so if you'd like more problems to do, you can go through your textbook as well. Have a nice day, and feel free to email me with any questions.